Hello all. In the last video, we discussed about detecting a cycle in an undirected graph. So what we discussed is initially we learned to find the union operations in sets, and then we applied the same concept to graphs as well. But what we did was we used this parent concept where all vertices belongs to different trees. We use this tree parent child relationship to do find and union operations, which will ultimately say whether there is exists a cycle or not. So but one drawback what we found with the in the last video was there can be cases where while doing the union operations, like you might end up adding all elements like that, like this, where you will end up creating a left skew tree. Like if you keep doing union operation like this, then your time complexity becomes order of v for each for each union, find and union. So that way for each edge, if it takes order of v, or like you have e number of edges, then your time complexity would be order of ev, right? Order of ev, like which is very high, which is very high. So what you can do is we can reduce your time complexity into order of e into log v using collapsing by find and union by rank method. So what is this collapsing find and union by rank? Let's discuss now clearly. Yeah, in the last video, what we saw was, like, initially, let's say I take this edge, okay, 0 comma 2. What you have to do, you have to find the parent of 0 and parent of 2. Now parent of 0 is minus 1. Whenever you encounter minus 1, what we discussed, that node itself is the parent. Okay, whenever you encounter this parent value. So here in the array we are storing parent values. So we were just storing the parent values, because of which it was giving you the order of v. Now we are making some tweak here. Now when you go to 0 comma 2, what is the parent? Minus 1. When you encounter minus 1, then this itself is a parent. So minus 1 minus 1. Okay, now like either you can do like this, or like, because 0 comma 2, since both belongs to the different, both parents are different, if I am doing union operation, what I have to do, either I have to make 0 as parent or 2 as parent. If I make 0 as parent, my tree would look like this, and if I make 2 as parent, my tree would look like this. So both are same, because this is not resulting in any increment of height. So what I mean here is, in either ways your height will get increased by 1. It's not that in this case your height will get increased by 3, and in this case it's just getting increased by 1. It's not like that. It's getting increased by the same number. So you can do either of these two approaches. So what I'll do is I'll make 0 as the parent, and then I'll like when I make 0 as the parent, 2 will come here. Okay, like what I'll do, I'll just drag 2 here. So now my tree looks like this. Yeah, let's wait, I'll add this parent child relationship here. Okay, now when I'm doing this, instead of just putting minus 1, now here 0 is the parent, right? So when you encounter minus 1, you can say that this itself is a parent. But instead of minus 1, let's add number of nodes present here. So now initially 0 was the only node present in 3. Now 2 had come. So when 2 has come, your nodes had increased to 2. Okay. Now instead of minus 1, like you put this minus value, negative value. But you add 2 to this. Let's keep this negative sign, but this number you increase it by 1, because you have two nodes in the tree, two nodes in this tree. Now 2's parent is 0, right? So this will become 0 obviously. So if you see here, instead of, like, anyway negative value is there. Whenever you encounter a negative value, that node itself is the parent. But instead of just storing minus 1, I am storing it as a minus 2. Minus 2 means I am adding the number of nodes present here. Okay. Here initially number of nodes was -1 and here like 2 was there, right? That was -1. I just summed it up, like added it up and made that as a -2. Now, why did I do that? Like when you traverse the graph completely, then you will understand the advantage of this. Let's take this edge 2 comma 4. What is the 2's parent? 2's parent is 0 and let's go to 0. 0's parent value is -2. Whenever you encounter a negative value, this itself is a parent. So my 2's parent is here my 2's parent is 0. 2's parent is 0 and let's see the 4's parent. 4's parent is -1, which means that 4 itself is a parent. So 2's parent is 0, 4's parent is 4. So now since both belongs to the different trees, I have to do the union operation. While doing the union operation, what you have to do is, here you have -2 and here you have -1. There are two cases while doing the union operation. Either I can put 0 as the parent and I can add 4 as the child. This is one way. Or what I can do is I can make 4 as the parent and 0 as the child. When I do this way, 0 as the child, then you will end up in a, like height would be increased here. This is one thing, right? 0 like 2 is present. You are doing, like you are processing this edge 2 comma 4. When I am processing that edge, 2's parent is 0, 0's parent is -2. So whenever you encounter a negative value, this itself is a parent. So basically 2's parent is 0 and 4's parent is itself. Here if you see, like just by visual representation, you can see 2's parent is 0 and 4's parent is this. While doing the union operation, there are two ways. If you are adding 4 here, you will encounter, like you will get this. But if you are moving, like if you are making 4 as the parent, 4 0 2 would be your final tree. Like if you see, this tree's height is lesser than this tree, so this will give you the better time complexity, because next time when you want to find out the parent of 2, here you have to do 2 steps, but here you just have to do 1 step. So this way what you can do is, this tree will give, like this structure will give you more benefit than this. So how will you determine which structure will give you the benefit? That is where this value comes into picture. Here if you see, this is -2 and this is -1, which means this 0th node tree has more elements compared to 4th node tree. So what you have to do is, you have to, like whichever node is having more number of nodes in the tree, put that as a parent, and whichever node is having less number of nodes in the tree, make that as a child. So here 0 has 2 elements, okay, 0 comma 2, and 4 has a single element. Now what you have to do is, you have to move 4 to this node, which means that this is having lesser number of elements. So make, like 0.4 like this here. Okay, I have done the same, because next time when you are doing the find operation, you will end up in lesser number of steps when you do this. Let's see the other edge, 3 comma 4. Now what is the 3's parent? 3's parent itself is a 3 itself is a parent. 4's parent, if you see, 4's parent is 0. Okay, what is 0's parent? -2. So whenever you encounter a negative value, that itself is a parent. So 3's parent is 3, 4's parent is 0. Both parents are different. Then I can find, I can do union operation. Okay. Now while doing the union operation, there are two ways. Either I can make 3 comma 4, right? Either I can make 3 as a parent or 4 as a parent. Now let's say I make 3 as a parent. Okay, now when I make 3 as a parent, 4 would be my child. In which tree 4 exists? 4 exists in this tree. So the complete tree will become child of 3. Now this is one way. 3, 0, 2 and 4. 4 will be like this. This is one way of doing the union operation. And the other way is, if you are if you want to put 0 itself as a 3, other way is you can do like this, because you are just making the union of 3 comma 4. Either you can make a tree in which 3 present as a parent or 4 as a parent. Here when I do this, when I make 3 as a parent, my tree's height is more. But when I make 0 as a parent, my tree's height is less. Okay. Now this will give you in optimized time complexity. So that can be done here as well. Here if you see zeros value is -2 and 3's value is -1. Whichever is having more number of elements, then you have to do that only, right? So what you have to do here is you have to, increase this number -3. Okay. Here this 3's parent would be 0. Okay. Here actually it should be 4 because last time you have added 4 as well. Okay. So now this is like, now you have performed this union operation. Yeah, let's move to other edge as well. And my next edge is 1 comma 3. Okay, here if you see, what is the parent of 1? 1 itself is a parent. 1 itself is a parent. Okay, now 3. Where does 3 exist? 3's parent is 0. Okay, so if you see here, 1 itself is a parent and 3's parent is 0, 0's parent is -2. Okay, this is what we have here. You have 0 here. Let me draw here. You have 0 here. Okay, you have 2 here and you have 4, 3 here. This is what we obtained from the previous steps. Now what we are doing is, you are doing this 1. So 1 exists here. So even if you see 1's parent is -1, which means 1 itself is a parent, and 3's parent is 0. Here if you see 3's parent is 0 and 0's parent is -2. When you encounter an empty value, that itself is a parent, right? 0. Okay. Now you have to perform union operation. There are 2 ways to perform union operation. One is, either make this 1 as parent, then you can do this way. This is one possible solution. And the other is, instead of, you can put 0 as the parent. Okay, 0, 2, 4, 3, and then here 1. Okay, 1. So if you see these 2 conditions, this will give you the lesser number of height. This will give you the more height. So this will give us the good time complexity. Okay. So as we discussed, compare the value of 0. What is the value of 0? It is -4. Okay. Now 0's value is -4 and 1's value is -1. Okay. If you just ignore this negative signs and compare, 0 has more number of elements. Okay, more number of nodes here. So when 0 has more number of nodes, automatically you should add whichever node has more number of nodes, that will become parent. So 0 will become parent. So this is our optimized solution. We won't use this. Okay, now this edge is processed. Now let's go to this edge 1 comma 0. Here what is 1's parent? Here you made 0 as the parent, and 1's parent is 0, 0's parent is 0. Okay, let me rewrite the values here. Okay, let me rewrite the parent values here. It was little clumsy there. Yeah. So if I write the values, like I am just drawing this way. So you have number of vertices 0, 1, 2, 3, then 4, 5. Yeah, let me do this way, 9. For 0, our value was -4, okay, because you keep adding it. For 1, it was 0, -4. For 1, it was 0. And then for 2, it was 0. For 3, 4, 0. Okay, all these zeros. And remaining all are -1. Okay, this is our parent values. Now, what I was doing, I was calculating this at 0, 1. Okay, 0, 1. What is 0's parent? 0 itself is a parent. Okay, 0's parent is 0. What is 1's parent? 1's parent is 0. Okay, let's see who is the 0's parent. 0's parent is 0. Okay, 0. So both belongs to, like, both parents are same here. When you say that, when you encounter this condition, then this edge will result in the cycle, that 0 comma edge will result in the cycle. Like, you can observe the same from the graph as well. Now if you add this edge here, then this will form a cycle like this. When you add this edge, it will form a cycle like this. When you don't have this edge, you don't have cycle here, it will end it up. Okay. Now whenever you encounter the parent, then you will say that that edge will cause you a, give you a cycle. Now let's move to the 4 comma 5. Okay. Now what is the parent of 4? 0. Okay. What is the 0's parent? 4. 0's parent itself is 0. 0 itself is a parent. Okay. Now 4's parent is 0. What is the other edge? 5. 5 value is -1, which means that 5 itself is its parent. So 5's parent is 5. So 4's parent is 0 and 5's parent is 5. So in this case, what I can do is I can perform union operation here. Now two cases, either make 4 as the parent or 5 as the parent. Now let's see, what is the 4's parent? 0. What is the 0's value? -4. Okay, -4, which means that if you ignore the negative sign, it has 4 number of nodes here. And for 5, you have just a single one, which means that it has a single node. So it is always, better to make a node with more nodes as the parent. So that's what we will do here. So what you will do here is, you have this 0, 2, 4, 3, 1, right? Now you got one more element, 5 here. So since we followed the concept here, 5. Okay. Now another edge is 5 comma 6. Oh, now we'll see the parent. So when I was making this 5, I should change this one as well. My parent is now 0. Now 5 comma 6. I'll process this edge. What is the parent of 5? 0. What is the 0's parent? 0 itself is the parent. So 5's parent is 0. And now 6. When 6 parent is, value is -1. 6 itself is the parent. Okay. Now 5's parent is 0. 6 parent is 6. Both belongs to the different sets. We can perform like a union operation. Either I can make 5 as a parent or I can make 6 as a parent. But let's see the values. 5's parent is 0. What is the 0's value here? It is minus, like whenever you add it, right, you add this, you increase this value as well. Okay. That like in the last step when you added 5, we did not increase this value. Now 0's value is -5 because there are 5 nodes in this children. Whenever you are performing in operation, you have to increase it by 1 here. 5's value is -1 and 6 value is -1. So if you ignore the negative sign, this 0 parent will have more number of nodes. So you put 0 as the 0 as the parent and you make the 6 as the child. Okay. What I'll do is, like, let me draw another one, like 0, 5, 2, 4, 3, and then 1 and then 6. Okay. Yeah. Now let's go to the another edge, 6 comma 7. If you see the 6 value, we like 6 parent is now 0, right? In the last case, like in the because 6 parent is 0 and even this value will become -6 because this has become parent, right? One more element got added to this. So this will become -6. Now our edge is 6 comma 7. What is 6 parent? 6 parent is 0. If you see here, 6 parent is 0. And what is 0's parent? 0 itself is the parent. And now let's see the 7th. 7th parent is -1, which means that 7 itself is the parent. So since both parents are same, we can do a union operation. We can perform union operation. While performing the union operation, what is the value of 0? -6 is the value of 0. And what is the value of 7? -1 is the value of 7. So 0 has more number of nodes. So whichever node has more number of nodes, that will become the parent. Okay. And now 7 will become the child. So what I'll do is, I'll do like this. 7's parent is 0. Okay, done. Now 8. 7 comma 8. What is 7's parent here? 7's parent is 0. Okay, and 8. What is 8's parent? -1. Minus 1 means 8 itself is a parent. So 7's parent is 0, 8's parent is 8. Both belongs to different sets. Now while doing the union operation, you cannot do it blindly. So whenever you are doing the operation, either 7 become the parent or 8 become the parent. So for 7, what is the value? 0 is the parent. For 0, what is the value? Minus 6. And for 8, what is the value? Minus 1. Okay, minus 1. I guess 9 is not there, minus 1. Okay, in this case, if you ignore the negative sign, 7th node has more, like 7th nodes tree has more nodes. So 7th nodes means 0 parent node. So this node have more number of nodes. So this will become the parent and you add 8 here. Whenever you add it, you increase this value also. Here if you see, you add this 8. Yeah, ideally this should be 8. Somewhere we missed adding it. Okay. Now 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay. If you see here, are there any edges? No. What we have done is we have followed the same process that we have done in the previous video. But here, while doing the union operations, what we have done is we have assigned rank actually. So whatever, like while doing the union operations, what you are doing is whichever is the parent, right? You are adding the number of nodes because let's say you have 0, 1. When 1 is getting added to this 0, what I am doing is instead of just putting minus 1, I am increasing the count to minus 2. So whichever node has more number of children while doing the union, if you make that as a parent, you will get a tree like this. Okay. So this, like while doing the find operation, what you can do, you just have to, if you want to find the parent of 7, you just have to go one step. Like, but if your tree is like this, let's say I like my tree might become like this 0, 6, 7, 8. So if my tree is like this, I have to travel more number of steps. But with the help of this union by rank approach, what you did is whenever you are adding the children to a node, you are adding the count also. So while performing the union operation, you consider that count and take action accordingly. This reduces the height. So our time complexity will gets reduced to E log V instead of EV, because here your height is optimized. Okay, that is one thing. And collapsing find. What is meant by collapsing find is sometimes you encounter a situation where you will have a graph like this. Okay, let's me do this. So sometimes while doing a find operation, you would have had like this 0, 1, 2, and you would have had 7 like this. So while finding the parent, what you have done, you went like this was your tree structure before finding the union, like before doing the union operation. Let's say you want to, this is 2, 7 edge you have and you want to do union operation. What you can do here is first you will do the find operation, right? You have to find the parent of 2, 2's parent is 1 and 1's parent is 0. You are traveling 2 steps and here 7's parent is 7. So while finding itself, you found that what it will return 0 and this will return 0. So whenever you encounter a situation like this, what you have to do is during the find operation, you directly point 2 to 0. Now I can do like this 0, 1, 2. Because while doing the find operation, I am making 2 steps. Then I found out that these 2 steps are not actually necessary. So in that case, I can directly, remove this edge and create an edge like this. Okay, I have done the same way. So this is called collapsing find operation. While doing the find operation itself, you are reducing the height of the tree, but like you are basically collapsing the height of the tree. Okay, so this is called collapsing find. And union by rank we have already discussed, because while doing the union operation based on the rank, we are performing the union operation. How that rank gets obtained is whenever you perform union of 2 trees, you are adding, like whichever becomes the parent, you are adding number of nodes to that node. So that becomes the parent. So in this video we discussed about union by rank and collapsing find. Collapsing find is just like while doing the find operation, if you encounter there are unnecessary steps, you can collapse the height of the tree. And union by rank is like, instead of just storing -1, you can store the number of nodes also. So that if you encounter -2 node and -7 node, so what you can do is you can make -7 node as the parent. So that will reduce the height of the tree. So this will reduce the time complexity from E into V to E into log V. Okay. That's it about union by rank and collapsing find methods. Thank you.